Good afternoon, everybody. Thank you for showing today. Welcome to Foundation Programming, day 15, I believe. We are reaching close to the end of our lessons. We're gonna go ahead and pick up from where we left off yesterday, which is gonna be Big O notation and common problem solving formulas. So let me go ahead and start share my screen. You should all be able to see the slides that we were covering yesterday. I believe we left off here covering, we started logs of n, right? So logarithmics. So why are logs important? So certain searching algorithms have a logarithmic time complexity, right? We'll get to these algorithms later in the course. You guys saw how that worked a little bit yesterday with my neat artwork. So hopefully I was able to put it into perspective. If not, that Grokking's algorithm book, like I mentioned to you guys yesterday, does a great job at doing that for y'all. Some of the most efficient, aka better, algorithms involve logarithms, right? Most notably, binary search, right? Binary search, which is a common search algorithm used in technical interviews. Binary search is also shown in that book I showed you guys, that Grokking's algorithm, which is pretty cool. So you can find it there. They'll explain it to you, and they'll explain it using logs, right? And they'll tell you the time complexity of it. Recursion at times involves logarithmic space complexity. You guys, for the most part, a large majority of you in here don't know what recursion is, but you will pretty soon. Logarithmic time and space comes up periodically, so it's best to be familiar with it. But you don't have to be an expert, however, right? And that goes with everything in here for today's lesson, and then the rest of the lessons for this week as well. Don't If you are struggling with any of the concepts that we talk about, or you still don't grasp like time complexity, space complexity, and just anything involving efficiency of your code or Big O notation or algorithm in general, that's okay, right? That is okay. This is what you would call kind of like computer science as well. Yeah, data structure, data algorithms, this is stuff that you learn in college as well. A lot of this involves pattern recognition. But honestly, I would say it's a skill, guys. It's a skill, right? What you call it, solving data algorithms using these, problem solving formulas and recognizing the patterns in code, whether it's like within strings, in a list, like figuring out what the trick is to it. It's honestly a skill that you have to develop, and it happens by working out your brain. I'm assuming most of you guys know that your brain essentially it's a muscle, right? You can work out your brain. There's different ways of doing that. Video games are a great way if you're into that. I know Kim's not, but you know, word puzzles, right? And stuff like coding challenges and recognizing patterns, a great way. So if you don't get it yet, or you still struggle with it, don't let that discourage you. It comes with time. All right, so in a nutshell, Big O notation is used to analyze the performance of an algorithm, right? An algorithm is pretty much just a set of is what we use to kind of like a set of instructions to kind of like achieve a goal, almost, right? Big O notation give us a high level understanding of the time and space complexity of an algorithm. And we already kind of talked about why we use Big O notation, right? And the number of steps or iterations over space. I'm sorry, over time. Big O notation doesn't care about precision, only about general trends. As the input gets really, really big, right? The time and space complexity of an algorithm depends only on the algorithm and not the hardware used to run it, right? And that's how we get rid of all those like external factors, like, oh, well, my computer is this, oh, and I have this kind of hardware, and yada yada. And I dropped Kool-Aid on my PC one day or my laptop, right? And now it runs slow. So, studies graph. Once again, I think this is like the fifth time we see this freaking graph. Just another representation of the comparing and contrast of the different runtimes, right? And how efficient they are. Dictionaries and lists in terms of Big O. So I'm sure you guys have used some of these, right? whether you are accessing stuff in the dictionary, we kind of talked about that yesterday as well, accessing stuff, whether it's by index or within the dictionary, or if you use certain methods, right? Some of the more common methods that you might actually see here, like filter, right? Filter, slicing, right? What is it doing? These methods, the things that you guys are doing to access this list in dictionaries is not just magic, right? It's not some fairy behind your window like just doing this for you, right? There is actually some kind of uh time complexity that's happening behind the hood. It's kind of programmed under the hood that you don't see this. And this kind of gives you an example of that, right? Insertion, right? When we're talking about dictionaries and we're adding a new key and value pair, that it's one, it's going to be instant thanks to the fact that we have that key value pair concept, the key being an address to the location of where the values are. Removal, same thing for dictionaries, one, key being the address, right? Accessing, same concept. Searching, and so searching a dictionary, right? How are we searching a dictionary? Not notice it's searching, not accessing, right? Accessing would be you're calling that item within that dictionary by its key, right? You know where it's at. You have that key. You know what you're looking for. You're gonna access it directly. Searching being you use something very similar to for key in dictionary, right? You're like looping through the key and value pairs, right? You're looping through the keys, you're looping through the values, or both as in items. That would be searching, right? We are doing that for loop, and then we're searching every single one from start to finish. Dict dot keys, dict dot values, dict dot items. Yes.
So I understand what you mean by the difference on the access and the searching, but when it's searching, isn't it still accessing the object itself, or how would it not get that data?
If we are searching for something within a dictionary, right? I
Mm.
want you to think of it as searching for something in a list. How do we search for something in a list?
Um, you just check in. Is this in that?
Yes, right? You can't that so the syntax would be is this in this, right?
Yeah.
What's happening underneath the hood? It is running a for loop. It's saying for I in range or however the length of your list is, and it's
Mm.
looping from start to finish every single item, and it's comparing it to whatever you're trying to check with the in method, right?
Mm-hmm.
Syntax wise, what you are typing is like, hey, is X inside of this list, right? To you think it's just opening this box like, hey, you in there? Oh no, you're not. Closing back up. No, what's happening with your computer? What it's running is that it's running a for loop. You just don't see that it's running that for loop for you,
Okay.
right? So the time complexity, how long it's gonna take? It's gonna take however long that list is, right? It's gonna be one.
Got it.
Accessing is a little bit different, right? Accessing, if we access an item in a list by its index, we have the address. The address is the index in that list. Hey, index one. I know where index is one is at, right?
Right.
It's like it's hashed in a memory location somewhere in your computer, and you can find it by that hash. Searching will be searching through every single item from start to finish in that list until you find what you're looking for. Make sense?
Yes, sir. Yes. Yes. Thank you.
All right, no problem. Dig dot keys. We saw when we talked about we did a Python crash course, talked about dictionaries. What is dot keys, dot values, dot items return to you guys? A list, right? We saw when we printed out the result of it, it essentially gave us a list of whatever the keys were, or a list of the values, or if we did dot items, it returned to us a list of key value pairs, right? So when we get dig dot keys, dig dot values, dig dot items, those methods, it's gonna be one because it's going through every single item in that dictionary and putting it in the list for you, right? So that's one, time complexity. Now the list a little bit more easier to understand. Insertion at the end, right? What does that mean? Dot append, right? Your dot append method, that's one. It is instant, right? Because it doesn't have to find where the end is. Like it knows where the end. Like the end, like there's nothing that it doesn't have to allocate any special memory, it doesn't have to move anything at the end of this bad boy. That's it. Pop that bad boy in the back, right? Same. Oh no, not same thing for the beginning. O of N. Why is that O of N? Who can guess why? Inserting an item in a list at the beginning of the list. What's happening when that happens?
I think every index has to shift, right?
Every index has to shift. Everything has to shift places, right? So if there's 100 items in that list, if you're going to enter something at the very beginning of that index, you're going through every single item in that list and shifting it one over. Therefore, it's going to be O of N being the number of iterations it has to shift something, right? Removal at the end, once again, O of 1 because it's instant. We know where the end's at, just chop it off. Accessing, notice the word accessing. Again, accessing something in a list. When we access an item directly by its index, that's O1. The index is mapped out for its location. We can use the index and it'll go directly to that space of wherever it's safe, right? Searching, that's a for loop. We're looping through every single one. That is O of N. Sorting is going to be when we use dot sort or sorted, as those sorted method, the time complexity is n log of n, and then we'll talk about that. We're gonna do a problem that we have to manually sort stuff, and you'll see why. Same thing with slicing. Slicing is gonna be an O of n, because how big of what you're gonna get back is gonna return to how much you're trying to slice off that list. Therefore, the size of that list is gonna be, or the size of n is dictated by however big the array or list is. So slicing is O of n. Filter reduce map O of n. Who's using it before? Kim, right? So when using something like dot filter, you're essentially going through every single one. You have some form of condition. You're like, hey, I want to filter out everything that's equal to 2. Or if I divide it by 2, it gives me like 0. And it does that to every single one until it finishes through the entire list. All right, that's a prime example of why it's O of n. It does that to every single item in that list. All right, O of n is going to be obviously the time complexity is dependent on how big that list is, right? The number of iterations or steps that we have to take. All right, before we move on from Big O and we talk about common problem solving formulas, do I have any questions about Big O notation? Right on. All right, common problem solving patterns, right? So this is not the silver bullet to solving all coding challenges, right? This is just some helpful patterns to be familiar with. What does that mean is Guillermo identified some of the most commonly seen problems that you guys encounter when going through like code wars for like the beginner challenges. These are stuff that like, oh, you know what, I've seen this. Oh, pretty much anyone that you talk to that just started coding has probably at least run into all of these type of problems that can use this solution, right? And he put this together and he came to the conclusion that, hey, most people can benefit by knowing how to do frequency counter, multiple pointers, sliding window, and the divide and conquer method, right? He came to that conclusion from his research. We will not cover the advanced ones. There's a bunch of other ones you can learn. You can look these up online on YouTube. There is and this is not even in a racist manner. There's like a bunch of indie professors out there that are great at doing this. They're masters at like math and patterns, and you can find all these like indie YouTube channels from indie professors or from India. They have like one of the largest amount of software producers or software engineers, software engineers of most software engineers are coming from India these days. So you can go online there. They do great work at explaining all these math concepts that I couldn't explain to you guys. So you guys want to know more of these advanced algorithms and techniques and patterns, check them out. I can give you guys some good YouTube channels too. But we'll cover some basic stuff. Also, that Grokky's algorithm one, solid. It'll have some stuff that we won't cover here that it can teach you. Check that out for sure. All right, so the first one we're going to talk about is going to be frequency counter pattern, right? I'm sure you guys have probably already seen this or have like seen a variant of it, might even use it in your own code. This pattern uses dictionaries to collect values and frequencies of elements, right? So we see here we have a list is of numbers between the 16 and 19. Notice that some of these numbers repeat themselves, some more than others, right? What the frequency counter pattern is supposed to do is essentially track how many times a number appears and then print that out for us. So the way that does it is essentially instantiating or declaring a variable called frequency, which ends up being an empty dictionary, right? This empty dictionary is the core concept of this pattern. It's being able to track it and using the key value pair concept for the dictionary to be able to save unique keys and then increase the count of how many times it appears. Right, so the code here, right? We say for items in the new list. Essentially, we're doing a for loop and looping through every single item inside the list. And what we do is they assign a key into the dictionary. The key is being whatever number we're looping through. And what they assign as a value, they call the new list variable, which is holding the list, and they use a dot count method to get how many times it appeared, right? And then they do another for loop again. They get dot items to be able to count the frequency. Who can tell me what's the time complexity of this piece of code?
Would it be Oven?
Why?
Because it's not just a single instance. You're looping through one array, and then you're looping through, and then you're creating a key value pair for each of those numbers. And that's why it's not nested. So it's not O of n squared, but it's not O of 1 because you're not just reaching from one dictionary and putting it in another.
Is it nested?
What was that?
Is it nested? I want you guys to pay attention to the code. There is something that's being done within this code that is making it not O of n, but O of n squared. Sure, there's not a deliberate written out nested for loop, but what are they doing on line 5?
Oh, they're counting. That's another whole thing.
That dot count method, guys. That dot count method. Dot count, once again, is not a magic fairy behind your screen that just I'm counting the 16. No, like it's running a for loop, right? So the moment it gets to line 5 and it's saving a variable in there, it's grabbing whatever items is, which in this situation, the first time it runs this for loop 16, and it's going to count it how many times it appears in the list. What dot count is doing, it is running another for loop. It is running a for loop and checking how many times 16 has appeared within the new list. Right, so dot count is a for loop. Therefore, it makes this a nested for loop, making it O of n squared. You gotta keep your eyes out for stuff like this, right? These methods that seem cool and they're convenient, although they're convenient, it will increase your time complexity, right? So be aware of that. And this is why this class is very important, because we go through live coding, right? You know, especially when we first start, we're like, oh, we got these cool methods like, you know, dot count and, you know, max and min, but we don't realize what they're doing. And then we start, I'm sure every single one of you guys use some form of nested for loop in your freaking assessments, or when you guys came in, right? Your coding challenges. I know, because that's me too. I did the same thing coming in. I had triple freaking for loops in there, right? Not knowing that's probably not the best way of doing it. And then in the same time, you're not realizing that you're probably actually using stuff like dot count, right? Min, max, and all this other weird stuff. And it's horrible, absolutely horrible. But now that you guys are going through this class, you're starting to identify, oh shit, okay, oh my bad, I didn't mean to say that. You start to realize, oh, you know, like this is probably not a good idea. All right. So besides the dot count method, let's ignore that for now. This method here, what they're doing, right? They're essentially creating a key. The key is a unique value, right? They're only gonna save items once. right? They're only saving it once, and then they're doing the dot count method. Whenever it finds 16 again, it's gonna override it, but it's gonna get the same answer anyways, because it's just running the 16 dot count method here. But what happens here, notice that at the end, what is frequency dot items? What does this dictionary end up having? It has the first number, which is 16. It has 2. The next number is 17. It's 3 times. Then it's 18. That appears twice. Then 19 appears 3 times. The dictionaries are very powerful because we know that keys have to be unique. They cannot be repeated. So we are able to use that to our advantage, right? And then we can increase the counts as well if we wanted to in the values. But what's up, buddy? That is working, Papa. Let's go with your mom.
Hey, Roger, can I ask you a question on that last?
Yeah,
Is line 6 like another nested loop? Is that 2 nested loops because it uses that dot items?
The items.
On line 6?
No. It's only running that once. It's still O of N, right? So it's gonna get to line 6, right? And it's gonna say, hey, for whatever yada yada dot keys, that's O of 1. But it's not running frequency dot items multiple times within the code block, right? Like the actual code block itself of what's being done multiple times is line 7. But line 6 only runs once. Think of it as individual O of N. Because it's outside of the actual code block of the for loop. Does that make sense?
No, but I'll keep reading that book you sent.
Okay, let's say, how can I show you this? Imagine they didn't do frequency dot items here, right? Let's say there's a line between line 5 and 6, and let's say that line they create a variable called like list of items. List of items equals frequency dot items, right? That one line right there is O of N, correct?
Yeah, just a minute.
Right. That one line is O of N.
Thanks. Okay.
And it's being saved into a variable, right? The logic of the dot items has already been handled, O of N. Now it's saved into a variable. And then instead of having frequency dot items here on this line, we have that variable we just created that's holding a list. Does that make sense?
I'm gonna have to process that myself some more slowly, but
I'll get back to it. I promise you. I'll show you in a bit, right?
thanks.
So, let's go ahead. So next, while you guys do this, I'll actually kind of draw it out for you. So we are going to try out here frequency constant.pi. It's the same pattern you see here. You guys are going to try it, replicate it from your assignments. So if you go to your lesson, where is my stuff at? Right, it should be lesson 11. Yeah, frequency counter. It should be empty code. Just check the readme. You'll even have the test cases for you. You're gonna write a function called same, which accepts 2 lists. Notice, right? It's gonna take 2 lists, and the function should return true if every value in the first list has its corresponding value squared in the list afterwards. Right. So what is 1 squared? 1 squared is what? Oh, 1 times 1. It's 1. So we see here, right? On the right side, 1 appears. So technically 1 squared, it's squared on the list on the second list here on the right. We go to the next value here, which is 2. What's 2 squared? 2 times 2 is 4. 4 does appear on the list on the right. Then we get to the next one, which is 3. 3 times 3 is 9. 9 does appear on the right side. So therefore, this is supposed to return true, right? So that's your goal. You're supposed to get both lists. If the numbers on the left appear on the same list on the right, but squared, then it's good to go. Also ensure that the frequencies of values must be the same, right? So they can't repeat, right? For example, let's say there's 2 1s on this list right here. Let's say it was 1 1 2, not 1 1 3. That means that there can not just be 1 1 on this side. There has to be 2 1s. Does that make sense, guys? It has to match how many times it appeared in the previous list, right? So the frequency does matter. All right, let's give it a try. I'm gonna give you guys 15 minutes. So I should come back at 6:30. I should come back at 6:40, right? Take the next. Man, 6:45. I want you guys to take 15 minutes to do this, and then still also be able to take a break. And then we will go over this together. In the meantime, Kim, I will get your answer to that previous question.
Can't hear you, Roger.
Oh, I hate when I do that, dude. I start off like super energetic, like very like talkative, like I sound like a YouTuber introducing himself, bro. And then you tell me like, oh, I can't hear you. Like, God dang it. All right, welcome back, guys. Let's go ahead. Let's get a round of how many people was able to complete the assignment with the allotted time. Who got it done? Okay, James, get in there. Thumbs down. Oh, Kim, you got it, Kim?
I don't
Okay,
know if it's
Kim.
best complexity, but it works.
Okay, Kim. All right. For those of you that got it, I might ask for some help here. We're gonna go ahead and code it. For those of you who were not able to, follow along with your code and then see where you might have gone wrong and where you could have improved. All right. Let me just make sure I am in the director I need to be. What is it called? Frequency counter. This one is nice to have more time on, but all right. We are going to look at the README. So what was the README asking for? Essentially, a small recap, right? Essentially, we were given two lists, right? They should be different. We need to return true if every value on the first list, right? The first argument is being passed, is found in the second list squared, right? And then making sure that the frequency of the values are also the same. Essentially, as we mentioned before, one should be found in the second list, one squared being a one, so it should be one. If you get a two, then for it to be in the second list, it needs to be squared. Therefore, you should encounter it as 4. And then for 3, you need to encounter on the second list as a 9, right? So we're gonna go ahead and try it out. We're going to create this function. It's gonna be called same, and it needs to take in a list 1 and a list 2, right? List 1 and list 2. And first and foremost, we can already knock out one edge case right out the bat is we can check the lengths of both of these. And if the lengths don't match, then we ain't doing it, right? So we can say if length of list 1 does not equal length of list 2, then return false right off the bat, right? Because the frequency doesn't match, right? We have to have the same amount on both sides. So if they're not the same, it's false. So that takes care of that part right off the bat. Next, we're gonna see, we're gonna declare some dictionaries, right? The main concept of this lesson was kind of using dictionaries to our advantage so we can keep certain count of the frequency of these numbers. So we're gonna say list 1 frequency, and it's gonna be an empty dictionary, and then let's check out list 2 frequency. Be like the dictionary, right? So we're gonna have two different dictionaries, one for each list, and this is when you track the amount of times it appears, right? So we're gonna say for number in list 1, if number in list 1 frequency, then I want to do something. Okay, so what am I doing? I'm doing a for loop for the very first list. As I grab every single item in this list, I'm going to compare it to my list 1 frequency dictionary. And I'm gonna see, hey, have I looped through this number yet? Is it in here? If it is, that means I've encountered it and I can increase my count by 1. In the event I haven't encountered it, then I'm going to save it in here as a key and set the value as 1, meaning I've encountered it for the first time, right? So let's do that. We're gonna say list 1 underscore frequency with the key, which is supposed to be number, plus equals 1. Right? We're increasing the count if it is in a dictionary. If it's not, that means we haven't encountered it. That means we have to save it in here. List 1 frequency number is equal to 1. Right? 1 is increasing the count. 1 is assigning it in the event it's present or not present within this dictionary. Next, we're gonna do the exact same thing, guys. The exact same thing, but for list 2, guys. So for number in list 2, and you're gonna repeat the exact same thing. If number in list to frequency, save the number of the key, increase the counts. If not, save the number as a key and assign the count to 1. Everyone understand what I just did, guys? And why I'm doing it the way I'm doing it? I'm taking advantage of the fact that I can access these dictionaries using the key value pairs, right? To check quickly without making a nested loop, right? By using the in list frequency and then calling it by the key, it's gonna be able to access it directly, right? And therefore it keeps it at O of N. If I had to use a for loop and I loop through all the keys and values, that would make it O of N squared. But because I'm accessing it with the in method for this dictionary, using the key as a reference, then it's gonna be O1. I'm sorry, not O1, O of N. My bad. O of N. Now, let's look. What is it giving us so far? Let's check it out, guys. Let's check it out. We're gonna see this print out list 1 frequency and list 2 frequency. Let's see what's giving us. Oh no, what am I doing? List 1 frequency and then list 2 frequency. I am a visual person. I like to see what my code is doing before I move on. We'll say same. And then let's grab these lists that we have. And then pass it in here. We're going to say Python frequency counter. Okay. So I'm getting back to dictionaries. We see 1, 1, 2, 1, 2, 8, 2 was encounter once, 3 was encounter once, 4 was encounter once, 1 was encounter once, 9 encounter once. So it's doing what it should be doing per this example. But what happens? How do we check if these are the same? Well, we still haven't done any kind of square rooting, right? So we're gonna have to go ahead and check. Not square root. We haven't done any to the power of 2 yet, right? So we're gonna have to go ahead and do to the power of 2. So how do we do that? Well, after we've assigned everything to their individual dictionary, then what I'm gonna do is it's gonna be a simple for loop as well. It's gonna start with for key, right? What I want to do is grab every single key of the first dictionary, right? I need to be able to loop through every single key because this is the actual number itself. The value is the amount of times it's appeared, but the key is the value. I'm sorry, not the value. The key itself is the number that I am comparing, right? The frequency is fine, but I want to figure out if that value is within this side here. To the power 2. So as I loop through every single one of these keys for the first list, I need to see if it appears on the right side squared, right? So to do that, we're gonna say for key in list 1 frequency dot keys, right? I'm looping through this list of keys, and I'm gonna say if key the power of 2 not in list 2 frequency. What did I just do, guys? I grab, let's say I'm looping through the keys of the first list, which is going to give me 1, 2, and 3. And in here, the logic, I'm squaring it right here on line 20. I'm saying, hey, 1 to the power 2. If it's not in list 2 frequency, it's going to check the keys, guys, by using that not in. And I'm able to check directly, hey, is it in here in the squared format? And if it's not in there, then I need to return false right out the back because that means it does not appear in my second list squared, right? Does not appear in there. But afterwards, if it does, then it doesn't need to return false, but I need to check if that key, its value, if it does not appear on the opposite side, right? So we're gonna say if list one frequency, passing key again, does not equal to list two frequency, and then I'm gonna pass in key again, but obviously this is supposed to be a squared version, right? After I've already established that key from the first list exists in the second list in a squared format, that means I know it's in there, but now I need to check how many times does it occur, right? Are they the exact same? Do they occur? Do we have the same amount of frequency on both sides, right? And that's what line 22 is doing. It's grabbing the value of these keys. And remember, what is the value? It's supposed to be the amount of times they've appeared within our list, right? So if it does not equal the same, then it needs to return false, right? So at any point, if any of these fail, guys, that means my entire answer should just return false. But if it doesn't fail and it reaches the end, there's nothing else to do but just return true, right? And then we can run this again. What's happening? I can print it. 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 There we go. Let's see it being printed out. It's true, right? So the first example gave me true. Let's try a false one. False, right? False. Good to go. Do I have any questions, guys, of how I've reached
Yes.
the result?
Can you
Okay.
explain line 22 again, please?
Yes, of course. Right. So once I've created my two dictionaries, right? Each dictionary is holding its respective numbers from each list, right? So as we saw here, I am doing a for loop of the first list, assigning it into list one of frequency, and then the value, what I'm assigning as a value is how many times I've encountered it within this list, right? That's what both list one and list two have. So after I've already done that, down here in line 20 and line 22, I need to compare both these lists. And this is how they look like, right? This is how they look like. I'm gonna see, hey, does we're gonna grab all the keys from list one. This is list one right here, right? List one frequency. This is that list. I'm gonna grab all the keys, and we see here the key one, key two, key three. Once I grab all those keys, I'm using them in a for loop. Well, we know, right? List two has to have the version of my list one keys, but squared, right? It has to be squared. And you can kind of see that here in our test case, our demo. One is encountered in list two, one squared, right? One by one, one times one is equal to one. So it is in list two in its squared format, right? How about number two? The number two that's currently in list one is encountered in list two squared, right? 2 to the power of 2 is equal 4. And we encounter that 4 within list 2, right? So that's what we got to do. We got to check if the key from list 1 squared is encountered in list 2. That's what we do on line 20. Once we ensure that every single number in the first list is encountered in the second list in a squared format, next we have to check how many times does it appear. Remember that discussion you and I had, Mike, about there being 2 2s here, right?
Yes.
But there's only one 4 here, which is the squared version of 2. So whenever it gets to the second 2, there's not another 4 there that it needs to have. That's what line 22 is doing. It's checking, hey, does the amount of times that 2 appears on list 1, does it match the squared version in list 2? If not, return false. right? Because remember, we're accessing here, these are accessing values, my man. We are accessing the values that are assigned to these keys, right? What is the value of key 1 on the first list? Right? The value is 1. What is the value of key 1 in the second list? The answer is 1. All right, so that's what we're doing. Next, how about number 2? What is the value of key 2 in the first list? That value is 1. It's only appeared once. What is the value of key 4, which is the squared version of 2? What is the value of 4 in the second list? It's 1. All right, they've only both each appeared once. That's what we're doing here. Does that make sense?
It makes sense to me. I just don't. I'm still not understanding why you key in list 2 frequency. Why the key is square, like exponential. It's throwing me off.
Okay, because let's look at this one right here. On the right side. Let's look at this demo. I want you guys to look at just this one right here on line 9. Number 1, right? This number right here, number 1. If it's squared, how is it supposed to appear on list 2? What's 1 squared? It's 1, right? It's not a trick question. When we do something to the power 2, we're multiplying it by itself, right? So 1 times 1. 1 times 1 is 1. So that means that the key of 1 needs to be 1 on list 2, right? That's the easy one. All right, next one is the number 2. What's the number 2 to the power 2? What's 2 times 2?
4.
4. That means 4 has to be on this side, right? Notice it's not here, right? When we separated these values into dictionaries, what happened was list 1 frequency is equal to this. Well, what's happening when we're sorting these into the list 1 frequency dictionaries, we're saying, hey, here is the first value I'm looping through. It's a 1. Okay, it's not within this dictionary yet, so I'm going to add it in here. This is the first time I encounter it, so I'm going to set the value to 1. Then I go to the next item, which is 2. Okay, 2, is it currently in list 1 frequency? It is not, so I need to add it in here. I'm going to add it as a key. Is this the first time that I encounter it? Yes. That means the first value that has to start off with is going to be a 1 because it's the first time I encountered it. I go to the next item, to 3. Is 3 in list 1 frequency? It is not. So I need to add it, right? How many times have I encountered the number 3? I've only encountered it once, so it has to have a value of 1, right? Now, let's say we encounter the number 2, right? Let's say there's an additional number in this list. It's to 2. So once I get to this number within this for loop, I'm going to say, hey, is this within my list 1 frequency? Well, let me check. Yes, it is. Here it is. I've encountered the number 2 before, right? And because this is my second time encountering it, I need to increase the value by 1. So line 13, the number 2, which is saved as a key, its value is going to increase by 1, so it's going to go to 2, right? That means that the number 2 has been counted for twice, right? So what I'm doing here on line 19, James, I am looping through the keys of the list 1 frequency, right? I'm saying, hey, for key and list 1 frequency, right? I can call this I, so it doesn't confuse you. I can say for I and list 1 frequency. I'm doing a for loop here, right? This is going to allow me to loop through every single key that exists in list 1 frequency. These keys should be 1, 2, 3, right? Make sense so far? So that's how list 1 frequency is set up. What's list 2 frequency? Well, let's read the problem. The second list has to be the squared version of the first list, right? The function to return true of every value in the first list has its corresponding value squared in the second list. That means if I wanted this line right here to return true, then I need to have the squared version of 1, the squared version of 2, the squared version of 3, and the squared version of 4. Essentially, this should look like 1, 4, 9, and 4. Right? They both need to have the same amount of numbers. 1 squared is 1. 2 squared is 4. 3 squared is 9. And then back to 2 again. 2 squared is 4. Right? That means the keys for list 2 frequency right here are the squared version of the keys of list 1 frequency. Does that make sense? I know I just explained it in a long way.
No, that's fine. I think the problem that I'm struggling with here is because the test case, the numbers in the second list are already squared, correct?
Where? Right here?
Yes.
Only I mean, yes, they are already squared, yes. But
So
they're
that's
missing.
why I'm getting
Uh-huh.
that's why I'm getting confused. I know they're not. What'd you say, Mike?
Once you finish saying, I think I hear what you're missing, and I think I can tell you what it is, but go ahead.
Go ahead and chime in, Mike.
Okay, so the key that is being passed in already has a value that's associated to it. So list 2 frequency is a dictionary, right? So that key that was passed in is a value. It's an integer. He is squaring it by 2, right? So with that value that he squares, he is looking for that key to be in there. Does that make sense?
Yeah, but
In our example, it's already squared because it's supposed to be squared, right? It's checking both lists. It's checking both lists.
I think it would help to remember that the I is referring to list 1.
Yeah.
Does that help make sense, Mike?
Well, no, it's James. I'm the one that's
James.
Oh, James.
Yeah,
sorry.
Look, James. So these numbers, right? These numbers right here are in list 1. These numbers right here are in list 2. Right?
Mhm.
I is supposed to represent these numbers right here. So list 1 frequency, and then I is going to end up being 1. I will eventually end up being 2. I will eventually be number 3. Right? What is the square root? I'm sorry, not the square root. The squared version of 1. We've already established it is 1. 1 times 1 is 1. Right? It's right here. It should be in here. So that means I, which is 1, is being seen over here as well, is I to the power of 2. Right? That should be 1 times 2 being 1. Therefore, it should be this. Right? When it gets to the 3, the I is going to turn into a 3, right? And the I is being put it here as well. This will be a 3. 3 times 2. I'm sorry, not 3 times 2. 3 times 3, right? Because we're doing to the power of 2, right? So 3 times 3, this will end up returning 9, which is this 9. Right? It is the squared version of the other numbers on the other list, right? So how do we get 9 here? Well, we squared the 3. 3 times 3, right?
Okay, I'm
Good.
just reading it wrong because I was imagining that the 9 was what you got highlighted, the I. I was thinking the 9 was already there, so you were squaring the 9.
These are all, remember, we're only looping through right here. This for loop is only looping through the keys of this list.
Okay, so it's only accessing list 1 frequency.
Yes, only
Okay.
accessing list 1. We don't even have access to this. But we know that the keys of list 2 need to be the squared version of this list, which is why we do this, right? Because if all the numbers are correct and they're the squared version, this should return to us, something that's true. But notice how we compare these values while we're going through this for loop. How do we access the key from list 2 frequency without directly doing a for loop? Well, we just squared it. Maybe it would make more sense if we did something like this, right? After we loop through the first keys, what most people would do, because it's less confusion for them, they would do for J and list 2 frequency dot keys. They will loop through both lists, right? List 1 and list 2. We're trying to avoid doing that, right? We're trying to avoid doing that. And the way that we know how we can avoid it is by just grabbing the key from the previous list and squaring it, because that's technically what it's supposed to be. That's supposed to be the correct answer. If it's not squared, that means one of these failed and they should return false, right? That means that the value isn't squared. We're trying to avoid doing a nested loop to get access to whatever the keys are in list 2, right?
Gotcha.
Right, so that's why we did it in this manner. If I wanted to get away from doing this, I would have to do essentially what I just showed you right now, where I do a nested loop, and I would say if I does not equal to J, return false, right? Because now I'm comparing the keys directly. I have access to both keys because I'm doing 2 for loops, right? Something like that. Obviously, there's some issues here of how this code will work, but essentially what I'm just doing is here I'm deliberately grabbing the keys from list 2 frequency and list 1 frequency. And to avoid doing some weird nested for loop, we just kept it simple like that, where all we did was loop through one list, and then we got the keys for the other list just by squaring it. We kind of cheated the system because we know that they're supposed to be squared, right?
Gotcha.
Makes sense, kind of?
Appreciate. Yes, that.
Okay.
Appreciate that.
I hope it does. I hope you're not saying yes because you're trying to give me a shut up, but I want to make sure you are actually learning and understanding this. If you guys can go home tonight and make sure that you guys feel confident with what you guys will learn, my job is complete, and that's all I want from you guys. So if you don't hesitate. Let me know after class, like, yo, like Roger, I have no idea what's going on. All right, and that goes for every single one of you guys. Just let me know, and I'll help you guys out.
Can I ask a
I have a
question?
question. Oh, go ahead, Kim.
Kim
I
did
was
start
thinking-
talking first. Let's hear it, Kim.
Does that, I don't understand how that works on a list that's not sorted.
Which part?
Like on line 7 of the test cases where it's out of order. I don't understand how it picks the right one.
So when we add them into the dictionary, that's where, right? And the dictionary, it doesn't matter when it's looping through. Whenever it encounters it, it's gonna add it into the dictionary with the key value pair.
I mean, on the last loop where it's checking that last one for I in list 1 frequency, doesn't that go through 1, then 2, then 1, and check 4, then 4, then 1? Or that's what I'm not understanding. If that's not sorted, how does it work?
Let's see. We grab the keys from the first list, and we say if I to power 2 and not S. Okay. We say I. If it's not sorted, these are dictionaries. These are dictionaries.
So they're
Right.
unordered. So that's why it works, right?
The order doesn't matter. It's gonna access the value. It's gonna grab the value that it needs, thanks to the key. So it doesn't matter where these key values are within this dictionary, right? This is the address. That key is the address of where it's located.
So if there's like on line 7, there's 2 1s.
On line
It's still
7,
gonna, on line 7, there's 2 1s in list 1, but there's only 1 1 in list 2, but it's still gonna know that and return it false.
this, do you know how it looks like in list 1 frequency?
Yeah.
Key of 1 with a value of 2. Key of 1 with a value of 2. There's not 2 1 keys, right? The keys are unique, right? Only one of each key. Remember how we created it here in list 1 frequency? If we've already encountered it before, which it's gonna get here, it's gonna get to that second one. Like, hey, is 1 currently within my list 1 frequency dictionary? Oh, yes, it is. So I'm gonna go ahead and increase that bad boy up on my value, right? That's how that it figures that out, right? So sure, there might be 2 1s here, but there's probably only 2 things in this dictionary: the 2 and the 1 as keys, right? This is gonna return false, obviously, right? Because there's supposed to be probably 2 2s here, because there's 2 4s here.
Mhm.
So one of these needs to be a 2, right?
Okay.
Essentially, I don't know if you're understanding, Kim. If not, what this should look like, right? After it gets sorted, what's gonna happen is gonna look like list. We'll say L1 is equal to 1, 2.
1 is 2 and 2 is 1. Yeah.
Yep.
And then 4 is 2 and 1 is 1.
List 2. Yeah, it's gonna look like exactly 4.
4 is 2,
2.
1 is 1.
That's how it's done, right? So when it gets here, when it's doing this check, it's grabbing L1 and then it's grabbing the key. The key is not gonna be in any shape, way, or form manipulated. It's just the raw key. It's gonna check key 1 and then key 2, right? Because we're looping through the keys in whatever order this may be. Here, we're grabbing whatever that key was, but to the power 2. So if it's 1, it's gonna be 1 times 1. It should be 1 over here. It's gonna find it over here. That's what this is gonna end up being. Once it gets to the 2 to the power 2, that's 4, right? This is gonna be 4. It's gonna find the 4. Does that make sense? The dictionary does not allow us to have duplicates. We are increasing the value if we encounter any form of duplicate. We are accessing that unique value by its key. So at no point do we have to figure out, hey, like, where is it at? Right? There is no duplicates in this dictionary. So although the initial list does have duplicates, we took care of it by creating a unique key, which is that number, and then the value is how many times it's appeared.
Okay.
Make sense?
Nope, but I'm going to work on it my own. Thanks.
Okay. Mike, you had a question.
Yes. So one thing, this is just observation, and maybe I'm right or wrong, but because of the way you've written it, even though it's more lines of code, because you're not using a dot count, it's doing less iterations.
Yes, this is old and time complexity.
Okay.
There's no nested for loops in here.
Okay. Yeah, because because as I was looking, because the way that I wrote it, it is shorter, but I use the dot count, and so I'm like, I am seeing something. So when we develop, how do we keep that at the forefront up? And that's because at times you want to keep code short, but in this case it's longer, but it saves time. So how do you switch to, I guess, that a particular way of thinking per se?
I would say first and foremost, make sure, number 1, is it efficient? And then I would say, is it neat? Right? When I say neat, I mean like, is it like, organized, the functions actually have some kind of order. It's not random BS everywhere, weird naming conventions. That's what I mean when I say neat. And then 3, I would say like how many lines of code they take to actually do this, right? I would say that's kind of like my order of priority, right? How efficient is my code, right? Once I make it more efficient, because sometimes like it doesn't really matter. Like when you start coding, get some stuff on there, get something on your screen, like get code working first. Once it's working, we call it refactoring. When we go back after we make sure it's working, we go back and clean it up. We go back, fix any kind of naming conventions. All right, maybe we find a much more efficient way of doing things. Maybe I like try and accept blocks, errors, like error handling, like go back and like and fine tune it.
Yeah, that's the part that I'm getting at, the efficiency, right? So using .count, you only use 2 lines, but with this is more efficient, even though it's more lines, right? So how do you, I guess, how do you, like, okay, for instance, if you were doing a code review and you looked at the code and you was like, yeah, it is shorter code, but the time is longer, so we need to switch it to this
It's
way.
gonna depend on what your job is, right? What's your company working with? What's the data that you're working with? Right? What is the point of this function? Are you sorting through millions of bank accounts at your Bank of America job because you're a data analyst and you're like, what are you doing? You know, what is your job doing? How much input is it going to be taking daily? Like, what's the traffic going to look like? Right? If it looks like you're probably going to have to be going through multiple, like a lot of data, maybe not having like nested for loops back to back to back is a good idea, right? Maybe increasing the type complexity is probably something that should be important for you. I think at that point, it doesn't matter how long this fucking code is. If it's taking 2-3 hours to run, what's the point of this code? Right? I don't care how pretty it looks. It's not running like it should be running. Make sense?
Right. Yes, sir. Yes, it does. Thank you.
No problem. All right. Let's go ahead and move on, guys.
I have a question. Not
okay,
related
let's hear it.
to. For some reason, I'm getting a type error. It says argument of type int is not iterable on my line 10, which is the for loop, or it's the if statement.
Show me. I like seeing code. Show me. I'll stop sharing. Let's see if someone else can catch it before I can. I hope you guys can.
Well, I ran into the same thing. I had to put int in front of it.
Whatever then. On line 10, if num in list 1 freak. And you're getting argument type and it's not iterable.
So I just put int num, int num.
Where, like on the list 1 freak? Right here.
On 10, right before it int num. I think that's where I did it. I tried it a couple different ways.
So like right here on num.
Yeah, I mean it says the word num, but it must not be seen it as num. That I know. I thought it was weird, but
let me see your where are you calling like the actual function? Can I see how your function? Hold on. Saying okay, 1, 2, 3, and then you're running it. It says argument of type int is not iterable. That means it's not recognizing what you're passing in.
Does the key square not in list 2 frequency make a difference?
What line?
Because
It's
I
not
think
there.
okay.
It's looking at line 10. It's stopping at line 10. If num in list 1 freak.
I think I see it. If you look at the else statement, he isn't assigning the key.
Yep, you're absolutely right. you are changing the value of that variable from a dictionary to an integer. So it changed completely what kind of data like type it was. It was no longer a dictionary. It was now become an integer. Good stuff. Mike, you are gonna go far, my friend. I don't know where you're gonna go, but you're gonna go far for sure. Good stuff. All right. We're gonna go ahead and move forward, guys. Good stuff. I love seeing that. Pumps me up. Let's move forward. Let me share my screen. So that took care of that frequency. We went over it. Cool. Next, so a not so great solution. Most of these, all the problems we're going to be doing today, you'll probably have the solutions here. I do not look at them. Don't cheat yourself. Treat yourself, right? We saw here list 1, list 2. They compare the lengths of both lists to ensure they were not different, because obviously they're different, and there's some, the amount of times they appear does not match. They then go ahead and loop through list 1. They square the value of list 1, right? And see if squared number is not in list 2, return false. Not very good, this method, right? This is a nested for loop, right? That not in is gonna check every single item in here until it finds it, because it's being used on a list, right? It's being used on a list. So because it's using not in on a list, it's gonna have to check every single one of these items in the list. Therefore, it's gonna be O of n squared until it reaches its final answer, and this is horrible. A much better solution is what we saw, right? Using the n operator for dictionaries is O of 1, but O of n for lists, right? So even though we're doing n, we're using the n operator in this code as well. It's being used on a dictionary, not the list. Right here, it was being used on the list, right? That's O of n. Therefore, this is a nested O of n algorithm, and that's not good. This is almost verbatim to what I have. So I'm not gonna spend any more time putting this. All right. Next, anagram.py. There is a cheat to this. Don't do it. Don't think about it. One of you guys is gonna think about it. Don't do it. Anagrams.py. Go to your lesson again. Let's check it out. Anagrams.py. Essentially, you're gonna get 2 strings. You're gonna write a function that determines if the second string is an anagram of the first. Roger, what's an anagram? An anagram is if you can make the same word with every letter within it, right? So anagram is a word, phrase, or name formed by rearranging the letters of another, such as cinema formed as Iceman. No, it's not like race car where you say a race car backwards and it's the same as race car. That's not necessarily an anagram. I mean, I think it is, but it doesn't have to be like directly backwards. It's the same word. That makes sense, right? It could be completely random as long as they both have the same letters. Race car and rat, not the same, right? Because car does not have a T, right? And rat does not have a C. Za and az. I'm very careful with how I said that. 2 A's and 1 A, right? Does not match. So false. Anagram, notice that Morgana is not the same as Marigan, right? So they're obviously, if it's done backwards, they do not match. Anagram does not match Marigana, but they both have the same amount of letters, and they both are encountered once, or the respective frequency that they have, right? A here is 3 times, A here is 3 times. N is encountered once, N is encountered once. G is encountered once, G is encountered once. R is encountered once, same thing over here, and then same thing with the M, right? So Once again, the second string is an anagram of the first. An anagram is a word, phrase, or name formed by rearranging the letters of another. Not adding, not subtracting the amounts, right? Just simply rearranging them in whatever order. All right, give the timing complexity of your solution as well. Time is 6:29. Go on a 10-minute break from 6:30 to 6:40. Once you guys come back, you guys have from 6:40 to from 7:40 to 7:55 to do it. And then we will continue. I won't be in my desk right now, so I'll be right back. Let's come back, guys. I just realized I was not. I did not pause the recording. Little unfortunate. Because that means you have to skip ahead 10 minutes. But yeah, so we're gonna go ahead and continue. Can you guys hear me? What am I looking at?
Yeah, I can.
Okay. So the last thing that we covered was anagrams. Let me go ahead and open this up. Essentially, we're supposed to be able to take in two strings, a left and a right. All right, it should look something like this. Now, who wants to share what they got? I can share mine, but mine's a one-liner. The last time I did this. Anybody at all?
I don't mind sharing mine. It'll explain why I got so confused on the other one.
Sure. Let's see it. I'm gonna show you guys mine afterwards. It's just that you'll understand once I show it why it's not a good example. Well, let's see what you got.
Can you see mine?
Yes, I can. Maybe zoom in just once if you can into your code. It should be good. If you are on Windows, it should be Control Plus.
I think I reset that to do something else, so it doesn't. It does
Okay.
something else.
Sure, no problem. It's fine. It's fine. Okay, I see your code. You took in string 1, string 2. You created an empty dictionary called myDict. That's cool for now. For letter in string 1, so you started a for loop, both of them in two different areas. All you did was check if letter was currently in the dict, then you would increase the count of its value. If not, you assigned it with a starting value of 1. Cool. And then you did the exact same thing, but you did it for the second string, and I'm confused here because you're adding the same thing to the same dictionary. So
I'm just removing it. I'm just removing it if it's there.
Okay. Why?
Because if it's there, then the value should always be 0.
Okay. So it should be 0. And how do you check at the end? What was your goal checking it was good?
Yeah.
You're checking if my dict called the key is does not equal 0, then return false, else it should return true. Okay. I see. And it worked, I'm assuming. Good, right?
Yeah.
Yeah. Yeah, that's a good way of doing it. Awesome. Who else? Who has something different?
I got something different that I've been working on.
Okay. You said working on something, assuming it's a lot. Let's see.
No. That's because I was thinking of a different way to do it, not like how you had just showed us, and so I just did it a little bit differently, making a list from the string, and then if it's found, pop it out, and
Yeah.
so that's what I was doing.
Okay. Are you sharing?
No, I'm sorry.
Or-
Hold on. I didn't know. Okay, hold on.
Oh, it's okay. You don't have to.
Okay.
We'll just move on anyways because we only have an hour left. I believe we have 2 more assignments. This is what I got. I cheated. The last time I did this, I don't know why I cheated. But it looks like this. I essentially what I did was I grabbed the first string, I sorted it, and then after I sorted it, I got rid of any kind of empty spacing that might be before and after. or in between, and then I join them together. That's it. I did it for both, but because they're sorted, you can just compare it. It is equal to the same. Obviously, I cheated, right? This is the easy way of doing it. It goes against the assignment, which is why I didn't want to show my. I don't know why I did this. I think maybe I was trying to do an example for somebody. But yeah, that was the way I did it. Tim's way was really good, solid. That goes per the curriculum. That's kind of what I expected from most of you guys. If you were in the same boat, even if it's not the same, at least using dictionaries to count frequencies, then you're on the right path to understanding just using dictionaries in general for frequency pattern, right? That was the goal. Okay. So that took care of anagrams.py. Next one, multiple pointers pattern. I like this one. This is one of my favorite ones. All right, so the multiple pointers pattern. All right, so this pattern consists of creating pointers that correspond to an index and move towards the beginning and or the middle of the string / list based on a certain condition. Notice we have one at the start and two at the end. What the variables start and end are isn't the number itself, it is the index, right? So if you are looking at code, start will equal to 0, end will equal to probably -1 or whatever the length of this is describing the last number. So that they're essentially grabbing the last index and the first index to grab the start and end. And then what's happening here is they're checking, they're looking for something. And if that number does not exist between these numbers, then they're going to decrease either the left side or the right side until they reach one number. That's kind of how this works, and you'll see it more in action. Right? It's very efficient for solving problems with minimal space complexity. Now, I believe there is a explanation. I'll show you the not so good solution. Do not look at the good solution, but we'll see the not so good. This is the not so good solution, right? So it is, as you see, a nested loop, right? We have for I in range of the length of the list, right? What index does I start off at? What does I start off at?
0.
0. Correct, 0. Then we have the nested for loop. Inside of this for I in range, we have for J in range. Notice that we have I plus 1. So they set the start of the range, right? Here, they didn't set a start. Therefore, the start of this range method ends up being 0, right? Here, they specifically stated, I want it to be whatever I is, but plus 1. That's the start point. And then what's the endpoint? They specify the endpoint, whatever the length of int list is. So essentially, I and J, they were giving 2 points. The first point, which is I, is going to be the start. It's 0. J, it seems to always be whatever I is, just 1 higher. And it's saying if the item that is found within index 0 of this list plus what's in index 1 is equal to 0, then return these two, right? So essentially, they're trying to find a combination of numbers within this list that when added together give you 0, right? And they're checking all possible combinations, right? All possible combinations, right? 0 with 1, 0 with 2, 0 with 3, 0 with 4. It's going to do that all the way until it checks all the combinations with 0, right? 0 being I in the situation, J being that number that's constantly changing, right? Once J finishes its first iteration, I goes from 0 to 1. And then J starts at the next number, right? And it's just essentially just checking every possible combination that we can find, see what can equal to 0, right? And that's how that pointer is used. You use two different indexes. Some start at the end, some start at the same area, but as you see just here, just one apart to check different combinations and different sides, right? That's the the magic with the 2 pointers. Now, using what you know about pointers, right? Grabbing 2 points and then comparing, contrasting, or doing some kind of equation. I want you to find a more better way of using those. See if you can figure it out. Let's go to our lesson, and it should be multiple pointers dot pi. So we have multiple pointers dot pi. Where's it at? Right here. All right, essentially you have a right function called sum zero, which accepts a sorted list of integers. Note it, sorted, right? The list is sorted, a sorted list of integers. That means we can expect that the far left, right, the beginning of the list will be the lowest number. The far right will be the highest number. This function should find the first pair where the sum is 0. Return a list that includes both values that sum to 0 or -1 if the pair does not exist. All right, give it a try, guys. And at the end, I also want to get your time and space complexity for solution. Time is 7:57. You guys have until 7:17. All right, let's get back, guys. We left off at multiple pointers. Let me go ahead and pull it up real quick. Oh no, do I not have it? I should have it. All right. Or I had it open in my notes. All right, so we are doing multiple pointers. Let's go ahead, open up the README and the file. Can you guys see my screen, or is that a no?
Nope.
Okay. Share. All right, so we had to take in a list, right, of a sorted list of integers and be able to pair them and find where the sum is 0. So we're gonna go ahead and create this function. It's gonna be define sum 0 and should take in a list, right? Now, we are using the multiple pointers method. And now one of the ways to do it, we essentially have to declare a left and right pointer. It's in some point of our code. I'm just going to go ahead and do it here all in one line. So I'm going to say left, comma, right is equal to 0. And then whatever the length of my list is, -1. So, wow, Roger, I didn't know you can assign 2 variables at the same time. You can. I think it only works at 2, if I'm being honest with you. No more than 2. So you can do something like this where you can declare 2 different variables. I did left and right. And notice that the left, it has 0 assigned, and the right, what it has assigned is supposed to be the last index within my list, right? Let's say the list here is 1, 2, 3, 4, 5, 6, 7. 7 numbers long. We subtract 1 to take into account the fact that we use 0 indexing. And it gets me 6. Therefore, the last index within this is 6, right? So I got the left index and the far right index already, just like this. So that's going to give me a start and an end pointer, right? Now, what I'm going to do is I'm going to start a while loop, right? This is what's going to have the main functionality where I'm going to be checking my conditions. And I'm going to say while my left is less than my right, I want to be able to check something. Essentially, I should be able to move my left pointer to the right, checking the different combinations, right? And so on and so forth. Now, I'm going to say while left is less than right, I want to say my current sum is going to equal to whatever my left pointer is pointing at. Maybe I should change this. Let me change this to array. That's why I had it like that on my notes. You don't want to name stuff by the names of data types. Like you don't want to call a string, or a list, right? So I'm just changing the name of my variables. Let's say it's array. Right, I want to get whatever my left pointer is pointing at. And then add that to whatever my far right pointer is pointing at, right? So essentially this will return to me the sum of -3 and 3, which would actually give me 0. It'll actually give me the answer right off the bat. All right, so it'll give me the current sum that I'm currently at right now, which is going to be the very first start. It'll check the very first numbers that I've assigned, right? After we get the first numbers, if for whatever reason that sum does not equal 0, that means we have yet to find the answer. Then I need to do something, right? I need to essentially change my left or my right. But if it does equal 0, then what do I need to return? Well, I see here I need to return both the left and right index, whatever my pointers were. So I would say array left for index 0, and then array right for index 1. Right. I have to return both of those numbers that when added together gives me my sum. So that's what I get if I get 0, right? We were looking for the sum, a pair that when I sum them together gives me 0. If I have yet to find it, then I need to do something else. I have to say if current sum is less than 0, I have to increase my left by 1. Why? Why, Roger? Why do you do that? Well, we know it's a sorted list. So if -3 and 3 added together is not 0, it's actually less than 0, then that means that my numbers are too small. Right? My numbers are too small, or even when I'm adding them together, I'm not even getting 0 yet. That means that whatever my far left number is, it is way too small to be added together to give me 0. So that means I probably need to move my left, drop whatever my left is, and move it to the right a little bit. Get closer to the higher numbers. Because remember, the list is sorted, right? I specified that keyword when I assigned this problem, the sorted list, right? So in my current sum, when adding both these numbers together, if it gave me less than 0, that means obviously my left number is too low. So I'm going to increase my left by 1, right? In the event I don't get 0, or my current sum is not less than 0, and it's greater, then I just need to increase my right, or essentially decrease my right, if that makes sense, right? So I need to switch this up to negative equals. Why? Because my right is at the very last index, right? If my current sum is greater than 0, that means that the two numbers I'm adding up together, they're way too high. I'm getting way too high of a number. So I need to decrease my numbers. And because once again, it's a sorted list, the fastest way to decrease it is to lower the far right pointer. Once this runs these 3 functionalities, right, it's going to go back around. It's going to check again. Hey, is left less than right? Have they touched yet? If they have not touched yet, if they have not crossed that less or greater than path, that means they have not touched yet. That means there's still numbers that need to be searched, right? And it's going to run again. So check the next current sum. So see, is it equal 0? Is it less, greater? Okay, adjust. Go back again. What's my new sum now? Less, greater? Is it 0? Nope. Let's adjust. Go back again. Let's keep doing that, guys, until left or right eventually they touch. Because every time we run this and we don't find the answer, we're moving them closer, either from the left to the right or from the right to the left, right? And then finally, if at some point we decrease our left and our right to the point where left and right are touching or they pass each other, then we need to stop this while loop, and we need to it'll stop, right? Because it's going to reach this condition. That means at no point did we find 0, so we should return -1, right? let's go ahead and use our examples that were given to us, and let's run it. And we see here, we see -3 and 3. That's good. -5 and 5. That's good. And then the last two examples are supposed to return -1. Did everyone get something similar to what I just coded out?
Yeah.
Awesome, Owen. James, I saw you smile. I'm assuming you did not.
No, I went on a reverse list rabbit hole that did not work well at all.
But do you see how cool this is, though? You see how this works and how you could probably use this method somewhere else? All right, awesome. Notice
Yeah.
that the keyword here was sorted, right? You might have to change this problem solving method a little bit if it's not sorted list. Keep that in mind.
Quick question, just to make sure, left and right are built-in methods, correct? And that's starting, like where you declared left right equals 0.
What about
Or-
this? These are not built-in methods. No, I declared these.
So can
Okay,
you explain
sure. All I
again?
did was
I know
let
what
me
it's
just-
doing. Just don't know how you got there.
these are just methods I declared, my man. Let me erase this. Maybe I shouldn't have done it this way because it confuses you. That's all I did. I create two different variables.
that closes it up. Thank you.
Thank you for asking that question. Yeah, this is all I did. I just did it in one line. That's just a way of doing it. You don't have to do it that way. If you've never seen it that way, I guess I can see how it can be confusing. But all I did was declare two different variables, my left pointer and my right pointer. That's all. But thank you for that great question. Who else, guys? Anybody else?
So I had got the answers right, but I missed the overall I want to say the lesson we were learning, but I can see the why this is needed as far as if you're doing it within an array. And so I had did it differently, but I got the answers though. So
Okay. Yeah,
Thanks.
highly recommend if you're one of those that struggles with stuff like this, go back, especially like you might not that I say that you're struggling, but because you didn't use this method, I would try to use it. So you can kind of all this is just adding tools to your tool belt. Right?
Yeah.
If you're able to solve it in a different manner, awesome. But I would still try to learn this way as well, so you know two different ways. Right?
Yeah.
Now you have more tools in your tool belt.
Yes.
Good stuff. Who else? Gary, you've been very quiet this
You
session.
leave it up for about 30 more seconds.
Yes, I can, James. No problem. I'll leave it up. Gary, are you there? Or are you struggling?
I'm here. I'm all good.
All right then. What do you think, Kim?
I just forgot to put the current sum equals this, so I have a lot of repeating list L plus list R over and over.
Okay. We're gonna do. Let's see. While James copies that, let me just double check the next assignment. See how much we have left on this. We might have one more. We have two more assignments. Let's see if we can do. I don't know. I don't know if we'll have time. I don't want to stop halfway. We'll stop it here, guys. We'll stop it here. I don't like stopping halfway within the lessons. Let me check everything else. Searching. Okay, we're gonna stop here. Let me stop the recording.